Welcome everybody, it's Niall McGorn here. Welcome to the second webinar in our series on robotic milking. Last week we looked at farm layout infrastructures for robotic milking, so looking at the grazing system. Today we're going to look at farmyard design options for robotic milking systems. So that conversation is going to be led by William Conlon. So last week we went through the area we cover, so you'll see there on the map customer base in the middle third of Ireland, and you'll see here on the next slide the sort of spread we have on service. So we've an engineer within 30 minutes of all our customers, so very well set up for the business that we're in. So as I said already, this presentation is going to be led by William Conlon, and William is part of our farmyard design and project coordination team. So the team is made up of William Conlon and Simon Moore. Their job is basically visiting customers or potential customers' farms, or people who are interested in farms, looking at yard layout setups, what options might be workable. And if there's a project commencing, it's passed on to either Seamus McDonough or Mark O'Farrell. Those two men come from construction backgrounds, so they're project coordinators. So once the plan is agreed, those two gentlemen take over responsibility for delivering the project on time and on budget. So they're the men who will be liaising with the builder, the plumber, the shed man, the concrete man, the electrician. So between the four guys to make sure that whatever is agreed is delivered. So what I'm going to do now is pass on to William, and William is going to start his presentation.
So hello, as Niall said, my name is William Conlon and I work on the farmyard design team. There's a chat function at the bottom of your screen if you want to put in any questions throughout the presentation, and we'll try and answer them at the end. So I suppose we have a decent bit of stuff to get through, so I'll get straight into it. So I suppose the first thing I do is the first visit I do out in farm is for someone who's maybe thinking of getting into robotic milking, who've seen them in operation other farms and think they might work on their farm. So what we're trying to achieve is an efficient farm layout to maximize cow flow to and from the robots. The cows flowing to and from the robots is really the success or the failure of the system. So we're trying to optimize the cows that come in from pasture, they'll milk and they'll go back out to their paddocks, and we're hoping for them to do that 2.2 times a day. So that's kind of what the whole system is built around. When I walk out on your farm, and the first day I'm on your farm, I'm looking at the area that's for development around the yard. And I'm also looking at the existing sheds that are in place and seeing how we might be able to tie in the robotic milking system with the existing sheds on the farm. I'm also looking for how I provide clean access. And when I say clean access, I mean access for the farmer to get into his robot room without having to go through a dirty area. And I'm also looking for clean access for the engineers to get in for when they're servicing your robot. We're also looking at, in a robotic milking system, I suppose we kind of split the yard up into two sides. So we have our clean side and we have our dirty side. And when I say clean side, I mean it's the area where cows aren't walking. So it's, you know, where you're feeding, where your milk truck is going in, and where you're moving through the farm. Then your dirty side of the yard is where cows are coming in and out off the Grazeway and in and out of your shed. So that's kind of where cows are moving the whole time. I suppose a traditional milking system is different to a robotic system in a lot of ways, in that, you know, when you're milking in a parlor, all your cows come in, they're locked in, they're milked, and then all your cows go back out. So you can afford that if silage or contractors have to be going by that route into the parlor, you can get away with that. Whereas in a robotic system, cows are moving 24/7. So you're trying to set up the system in a way that the other activities around the yard can work, I suppose, independently of the cows being milked. So whether that's looking and see where a milk truck comes, we're looking and seeing where we're feeding silage. And I suppose a lot of that is incorporated into the type of system the farmer is running as well. So that first visit, we're really trying to get a handle on, you know, when you're getting out to grazing, how long your grazing season is, how much land you have around the parlor to be able to support, you know, the number of cows you're thinking of running. So we're trying to get as much information off you on that first day, so that we can come up with a plan that I suppose it'll work, you know, throughout the grazing season, especially at the shoulders of the year where you may be making a certain amount off cubicles. And we're trying to do all that in a budget. So, you know, you're talking to the farmer and seeing where his budget is and what he's hoping to spend, and you're trying to do a design around that. So then that'll, I suppose, dictate, you know, what level of building work you do, and what, you know, if you're going to go on a new build or if you're going to develop the existing sheds. So if we look at this yard here, I suppose this is a farmer who swapped over about a year ago from sucklers over to robotic milking. So the shed down on marked with the green square, this shed is a 4-bay slatted unit. For sucklers, there's 3 tanks running across it, and there's a creep area on one side. So the decision was made to situate one robot in the creep area, so to be sitting just off a slatted tank. And then this year he installed the second robot. So again, just fitted in nicely beside it and sitting off the tank. We ran 2 rows of head-to-head cubicles down across this shed, which would give him enough numbers for one robot. So then he's looking at, for this year, for next year, maybe developing on more cubicles in this area. So then out to the side of the shed, we went with our Grazeway. And we brought a flow channel out from the existing slurry tank out underneath this Grazeway, to be an area to help collect the dirty water and the dirt that'd be in this area, because it is a high traffic area. We see here that we have cows moving either way away from the Grazeway. So everything is that side of the yard, and it's away independent from the rest of the yard. So now that we have our robot, our Grazeway, and our cubicles in place, and our grazing infrastructure, we're looking to see how we situate the other items that are needed around the yard. So for a new entrant, we're looking at where we can situate a dairy and a bulk tank, that, in an area that's going to be a cost-effective investment and work well for the milk lorry coming in that is not impacting. So the decision was made to put it into an existing shed that's marked here in the blue square. So the dairy was put in there. We see here with this arrow is where the main access into the yard. So this is where your milk lorry will be coming in. He'll swing around, he'll pick up his milk, and he'll drive back out without, I suppose, impacting on the rest of the yard. So he's very much independent, and he's in a clean area as well. So again, this is your clean side of the yard. We also brought the milk then underneath the ground from the shed over to the bulk tank. I suppose we have the bit of an advantage in robotic milking system that, you're milking little and often. So that you're not, you can afford to pump milk a bit of a distance away to existing sheds if they are on the yard. So this just meant that the farmer didn't have to turn around and develop a dairy over beside the robots. So again, it just helps keep costs down when you're going with the system. Again, we also installed a small office and a compressor room adjoining the dairy too. So you see that's a very simple kind of a layout, but it gives you an idea of what we're trying to achieve when we walk your farm and with the view of maybe going robotic milking. So then I suppose if we look at the layout options for robots, there's 2 main options that you have. So the first one is probably a head-to-head layout. This is where the 2 robots are just sitting back off a tank facing you like in the picture. And cows enter from the front and exit back onto the tank again. So that's generally what you'd see for the 2, maybe 3 robot farms up to about 200 cows. And then for those larger herds, we're looking at a checkout system. So we see here, this is a checkout system where the robots are in line. So we have 1, 2, 3, and 4 robots. Again, it's generally used for those larger herds. So this is a 240 cow herd, those 3 robot plus farms really that are looking at running higher numbers through a robot. This was installed into an existing Parlor area on a farm. So the first one we're going to go through is maybe a bit of, before we go into the detail on the 2 layout options, we're just going to talk a bit about a few aspects around the robot. So the first thing we'd focus on is maybe space around the robot. So especially in a head-to-head system, whether it's or a single robot just sitting off a tank, you're looking for about 4.5 to 5 meters from the robot to that first obstacle. I'd akin this area to being your collecting yard if you were a conventional milking system. This is the area where you're going to have a high traffic footfall of cows. So that every cow is going to be coming in, milk 2.5 times or 2.2 times. You're going to have 300 cow passes in and out in this area. So it's a very high traffic area that you want to be easy to clean and easy to manage. So we generally recommend running a tank across in front of your robot. And in a lot of cases, on existing farmers swapping over, you're going to have tanks already in the farm that we're probably going to try and make use of in that aspect as well. But just give that area for, if you do have 10 or 15% of the herd that come in at any one time, that they have the room there. I suppose it's also important for if you're, at the shoulders of the year, as maybe in the spring, especially if we get a bad spring and cows are in milking off cubicles for a few weeks, that they have good lounging room around that robot. Another aspect that we're looking at when we're going out to farm is we're trying to incorporate some sort of separation area to one or maybe both sides of a robot. So your options there are to go with maybe a straw or a cubicle area or some sort of combination of both. Generally, it'd be used for the likes of freshly calved cows, for lame cows, cows maybe drafted for AI. And the beauty is that it's they're all routed to this area from the robot. So when your cow goes in to be milked, if you set her to be drafted off to this area, she's automatically guided in here. When they're in this area, then they'll be able to feed. They'll be able to lie down either on a cubicle or on straw, and they'll be able to cycle in through the robot, but they'll only be sent back out to this area again. So, if you have lame cows that you want to target for footbaths for a few days, you can leave them in this area, run them through your robot, and they'll have access to a footbath that might be in the corridor behind the robot. What we'd also see, especially at this time of year, is, if you have cows bulling and they're automatically drafted off because they're in heat, you don't want them standing on concrete. A couple of cows stand on concrete bulling and one slips and, damages their leg. It's what you want to avoid. So we try and link up to a local paddock adjoining the shed where possible. So this is a small, maybe half acre of field near the robot that a cow can go out through the separation area, go out into that local paddock, lounge around there, come back in, be milked, and she'll only be sent back out to that area. So it means if you have cows that are drafted off from 6 in the evening until 6 in the morning, that they're all there waiting for you for when your AI man comes, maybe at 8 o'clock in the morning, you can run them in from there, put them into this separation area, put them in the headlocks, AI them, and job is done. It just means that they're there and they're convenient to you, and you don't have to go open a bale of silage to feed them in that separation area at this time of the year. And look, that a lot will depend on the farmyard layout, whether you're able to incorporate this area or what size of a separation area you are able to incorporate. We're also looking, I suppose, at what the existing facilities are on the farm, and do you have calving facilities? Do you need calving facilities? And are you trying to make one of these separation areas big enough that you can calve cows in it as well? So, we're looking at the whole kind of farmyard and the whole way it works, and the location of all your other sheds around the farm. The other benefit that it does give, if you do have, say, a 2-robot head-to-head system and you have a straw separation area to one side, it does give you the option that there's the potential room for a 3rd robot down the line if you ever did expand numbers. Look, nobody knows what land block might come up or how things might change. So it's always good to leave yourself that option that you can expand. And that's something that we put a lot of focus on as well in the design, because over the last year or so there's been an awful lot of add-on robots that have gone in. So someone moving from 2 to 3 robots, or someone moving from 3 to 4 robots. So we're trying to leave it open that you have that option down the road if possible. So then another factor that comes into how we lay out our farm, we're looking at our Grazeway location. So first of all, what is our Grazeway? It's the drafting gate that regulates where cows go. So every cow that's coming in from milking gets free access straight into the robot area. They can go through the robot, or they can try the Grazeway. The Grazeway then, if they're due to be milked, it'll lock them back into the shed, so it won't let them out. And if they're not due to be milked, it'll let them out to either the A, B, or C paddock, depending on the time of the day and the cow. So in the last couple of years, we've seen a lot of grazeways are being generally located on a tank or some sort of flow channel. So this makes it an easier area to clean, and just leaves it so that it's an easy area to wash down. Because again, it's a high traffic area. So if you have a 70 cow herd, it's going to pass through this area in and out, 300 to 400 times a day. So it's a lot of movement. So we generally try and incorporate some sort of static tank or flow channel into this area. If we look at this example, and it's what you'd see in a lot of places where you'd run the one tank going in front of the robot and out underneath the Grazeway. So you're getting away with installing maybe one long tank to do both jobs. And look, there's a bonus there in slurry storage and capacity too that's always under pressure. So we're going to look at a few of the different designs now and kind of talk through the head-to-head and checkout. So we see here, this is a typical 2-robot head-to-head design. So this was installed over the last winter for an existing dairy farmer. So a lot of, I suppose, while the picture looks nice there's a lot of thought and a lot of work goes into getting it to that stage. going over and back with farmers maybe 4 and 5 times to get a design that worked for the farmer, but also worked for us and the cow. Because the cow is central to the whole thing. You know, you need to have a design that the flow will work well. And I suppose the team have been involved in a lot of installations. So we have a good experience, I suppose, of different jobs that have been done. So we're going to look at this in a 3D model just to maybe talk around what's around the robot. So if we look at here, we have our robot room 1 and robot room 2. So we'll see the robot room 1 is generally bigger because you're going to have not only a robot unit, but you're going to have your central unit in there as well. What your central unit is, it's a red cabinet that kind of acts as the brains of the robot. And this can drive 2 robots. So, you know, you have your vacuum pump and your boiler in that area. And it's also where all your chemical and your teat dips are sucked out of for the robots. So the first robot room is always that bit bigger to generally incorporate the central unit. Then behind this area, we have an office and we have a milk tank room. You'll also have a small area for a compressor. And again, they, you know, fit in tidy behind the 2 robot rooms. To one side of the robot rooms, then we have cubicle separation. And to the other side, we have a straw separation or a calving area. We also have a small handling area in this part of the shed. Here we have kind of a pit and a bit of a herringbone crush, so a farmer can dry off cows maybe at the back end of the year. And then, like all the designs we've seen so far, we have a tank running across in front of the shed. So again, you know, while it looks a fairly simple layout, it takes a lot of planning to get it to this stage. And I suppose the 3D drawings help the farmer can visualize it and see how they're going to, you know, the actual sizes and how it would fit in their yard. So this is the job then when it was completed. So again, we have our tank running across in front of the 2 robots. You see the meal hoppers above the robot rooms, mass concrete panels generally above the robot rooms because they're quick and easy to install. You generally have a couple of water tanks above the robot rooms as well. You see on the near side of this robot room, there's a sliding door, a sheet of metal. This gives the farmer access into the robot room to drop in, I suppose, large barrels of chemicals so that he doesn't have to bring in small barrels in. So it's just providing that bit of an access route for a job that might have to be done every couple of months, but when you have to do it, it's convenient to do so. So if we look a little to the left now, we have our calving area and straw bedded area. So again, you have a calving gate towards the back of this area, a length of feed span the cows can eat, and they can still cycle in around the robot and back out to this area. We also have the small pit and herringbone crush that's not yet fitted in that picture. The pit there can swing up on a hinge, and you can step down into maybe a 3-foot deep pit to get in behind the cows for treating. We looked in on the other side of the robot. We have our cubicle separation area and our length headlock and feed barriers. So again, cows can cycle in from this area through the robot, and they'll only get back out to this area. So on this farm, there's about 7 cubicles in that area. Now we're looking at the same layout, but we're looking at it from the top, just I suppose to give you a feel for how cows move throughout a robotic milking system. So again, we have our straw separation area, our calving area, and we have our cubicle separation area. So we see the 2 green arrows indicate the cows going into the robot. So both of the cows are entering from that slatted area in front of the robots and entering into the back of the 2 robots. If you want to separate these cows, they're automatically drafted down a center corridor between the 2 robot rooms, where they can be put left over to the straw separation area. They'll go through a set of one-way gates so the cows can't come back in through that corridor. And they can go in that straw separation area. They can lie down, they can eat, but crucially, they can also cycle around the robot when they're due to be milked. So they have that free access. I suppose they have that bit of priority access as well, that they're generally not going to be going through a herd of cows to get to the robot. Your other option is then, if you separate and you come to the end of your center corridor and you send cows down right to the cubicle separation area. Again, there's a set of one-way, what we call Texas gates. They only swing one way, so the cow can go through them, but they can't get back through that corridor. So it's just freeze access. Again, cows can cycle around on that robot, but they'll only be sent back to the cubicle separation area until you say that, you know, you're happy for them to go back to the rest of the herd and you let them out. And at that case, or a cow that comes in and she's not for separation, they just come out of the front of the robot, back onto that slatted area. So I suppose with this type of a layout, what you're really looking at is cows, free flow of cows going into the robot and back out to the robot onto the same tank. So, you know, as we move up numbers, that's when we'd look at maybe going with what we'd call a checkout system. So we'll move on now to just talk through, I suppose, what a checkout system is and how it works. So here we have kind of a different orientation of robots. They're all in a line along beside each other. We'll see here 1, 2, 3, and 4 robots. And cows enter these robots directly from behind. Again, you're going to have a slatted area that they enter from because like the other system, there's still going to be, it's still a high traffic area where every cow is entering the robot from. We'll see there that they, you know, they don't take up a whole lot of room. I suppose, you know, to get 4 of them in, you get them into a fairly compact area. So here we have an example of a checkout system. So this went into an existing parlor and the walls were simply just cut out to give the access points for the cows into the robot. So we see 1 cow, 2, 3, and access to the 4th robot down the end. So again, you're looking at having that slatted area before you go into the robot. And look, some of the advantages of a checkout system can be that you get, you know, you're not having all your cows coming out on the same area that cows are going in on. So it frees up a bit of space. We see here, so this is looking at the opposite side of the robot, so where the cows come out of. So again, we have 1, 2, 3, and 4 cows coming out. You generally like to try and have them coming out onto a bit of a flow channel or a slatted tank, a small slatted tank in that area, because again, it's your high traffic area that you want to try and keep clean. So, you know, you're trying to factor in when we're out walking your farm, we're trying to see, you know, is it a checkout system you're looking for, you should go with, or is it a head-to-head system? And I suppose you're looking at the number of cows you have, the number of cows you'd like to get to, and what the land would be capable of carrying. So, you know, we talk through the different options, and we have a lot of farms now that are running from 3 to 6 robots, you know, milking up to 420 cows in checkout systems on grazing platforms. So then when all these cows come out, they're going over your flow channel and you're going back into your grazeway again. And here they can be sent to your A, B, C blocks. If they haven't been milked, they can be turned back into the area, the other side of the robots, or they can be sent to the likes of a local paddock as well. So you're just, I suppose you're given different options. The advantages of a checkout, I suppose, is sometimes it can be easier to get heifers to move through them, you know, if you're working with large numbers. So here we have a cow coming out of a checkout style system and again onto that meter wide of a flow channel, and she'll exit out towards the grazeway. So I suppose that's the 2 main orientations that we have for robotic milking. You're either your head-to-head, just sitting off a tank, or your checkout style system. And whichever system, you know, suits your farm, it'll depend on, you know, what you're trying to achieve. So we've kind of gone through the orientation. So I'm going to go through a few quick examples of farmers who have converted over, new builds, kind of retrofits, just to give you an example of the kind of jobs we're working with, because unfortunately there's no 2 jobs really the same. Everyone needs a bespoke plan. And you know, the team have been involved with installing probably over 300 robots at this stage. So, you know, there's a lot of experience and a lot of different plans, and I suppose a lot of different sheds have been seen in the time. So if we look here, we have a simple kind of a 4-bay A-frame shed. Again, it was a suckler farmer who converted over. He wanted to try and get in for as low cost as possible. So that we installed the robot in a creep area on one side of the shed. And again, because of that, it was sitting just off a tank. So again, you have your cows entering and exiting the shed on that slatted tank. We put precast cubicles to one side of the robot. So this gave you the option that down the line when the second robot goes in, that these cubicles could be lifted out. And the farmer actually installed that second robot in his second year of milking. So again, just remove these cubicles and built the robot room. So this was when the first robot was installed. So there was 2 head-to-head rows of cubicles run down the shed. The farmer was feeding in an L shape around the edge of the shed, so he had ample feed space. And the robot just sits nicely in the back of the shed in the creep area. Very simple robot room, built with blocks and then just timbers to roof it, and then just a bit of panel put on the ceiling. So again, a very, very simple kind of an installation. Then this year, the farmer decided he'd go with the second robot. So again, took out those precast cubicles and just fitted in the second robot beside where the first robot was. So again, a very, very simple installation and very low cost. You know, this farmer will be out in, is able to get out to grass in February 99% of the year. So I suppose he has that good land base to work with as well. The cows can get out early. The next job then is another farmer, again, who converted from sucklers over to dairying. But this farmer, I suppose he wanted to stagger his investment over a few years. And, you know, like a lot of the jobs we go to who are new entrants going in, you're trying to put a plan in place of what you should do in year 1, what can be done in year 2, and maybe what can be done in year 3, depending on the situation and I suppose the setup of the farm. There's no two farmers the same, so you just have to work with what people are able to do. So the first year then he went and put a small lean-to structure that you can see in the picture here off an existing A-frame shed. So again, this is looking from the inside of that lean-to structure. So you have the single robot, and again, he's built the room for the second robot for when he does expand, hopefully down the line. Again, you have that tank running across in front of your robot, you know, that high volume area. But this farmer, I suppose he did something a bit different. He decided he'd bed on straw for the first year when he had his 70 heifers. So this is the shed looking in that's facing the robot. And he got away with bedding on straw for the first year. Now, the thing is with that's very much dictated by the part of the country you're in. And I suppose the availability you have to straw and how liberal you are with the straw. You know, this farmer, he bedded well because he knew it'd be worth it and it'd help save the cost. And again, he was milking, he had to milk because the wet start to the spring, he ended up milking 60 cows off straw for the first couple of weeks. And he didn't have any issue with them. He said it worked well and he was happy with it. And he's considering whether he'll stick with straw for next year or not. The other investment I suppose you're looking at doing, or that this farmer did, was a 100-foot tank that ran in front of the robot and underneath the Grazeway. So while a 100-foot tank wasn't needed to incorporate all these, I suppose, aspects, it was done in such a way that it allows for future expansion, and he'd still have the capacity in the yard to deal with that future expansion. So it's, you know, it's whether you turn around and put in one smaller tank now and have to do another one in a few years' time, or just put in one big one now that'll give you the, I suppose, the comfort and the capacity to manage the slurry over the winter and not have to be pumping to other tanks around the yard. And then he did something a bit different as well for the dairy. When we first came out and walked the farm and we were discussing options as to where he could situate the dairy and how it could work, there was an existing old shed, traditional farmyard, or farm shed on the yard. So we looked at maybe could that be potentially developed. The location was perfect because it was on the way into the yard. So there was room for the milkman to come in, swing around, lift the milk and not have to interact with the rest of the yard. It also helped that he could reduce building costs because, you know, he'd have to turn around and replicate this building somewhere else otherwise. So he decided to put his milk tank, and he built a small area for his compressor and his office as well. So again, it's just to try and, you know, keep costs down when you're converting over. So the inside the shed, that's the inside of the dairy. Then he just plastered out the walls and made it a sealed area. And the bulk tank fitted in nicely to it then. Again, this is a bit away from the robot, but very manageable to pump across to it. So if we look at, I suppose, a breakdown of costs of what this farmer spent to get in. Labour for the entire job was about 28,000. The concrete came to 13,500 for everything. The slats over the tank were 6,500. The concrete slabs, which were over the robot rooms, were 1,300. The shed itself, the bit of a lean-to structure that he built, was 8,500. So the total cost of the building work involved came to 57,800. Of this, the tank cost approximately 27,000. So you can see, you know, it left the rest at about 30,000 for the rest, but you can see the investment that's needed in slurry storage. And I suppose that's where a lot of farmers, you can see a lot of money being spent if you are swapping over, if you don't have existing sheds on the farm. So you're just trying to work with what's there or what's needed and develop it in such a way that it, you know, it either leaves scope for expansion and makes it easier to manage for now. So then we have another farmer here. He was an existing dairy farmer and he decided he wanted to swap to robotic milking. He'd had long enough milking in a parlor and was just, the body was not cooperating with him. So he decided to go down robotic milking. So you see here again, it was a very, very simple room that was built to hold your robot and your central unit. So we see that grate there in front of the room is where the cow will be standing when she's to be milked. So he installed it beside an existing parlour, and I suppose this gave him the bit of flexibility that he didn't have to install it during the dry period. He could work away on the build and it wouldn't impact on cows being milked. He also had to extend the tank out towards the Grazeway area, again to give him an area that he could wash down to. You know, we see here it's a very, very compact build. The room had to fit in between the existing parlour on your left and an existing shed on your right. So he also put a bit of a shed over this area too, and that gave him separation as well. So the total cost to this farmer on the building work was about 10,000. If we look to, again, we're trying to achieve that separation area. The cow, when she's milked, if she's to be sent to separation, is going to be sent down one side of the existing parlour, and he's going to keep the other side of the existing parlour then to treat cows, you know, to dry them off in the back end of the year. And then when cows come back from separation to be milked, they come up passageway inside the robot room. So again, just a very, very, I suppose, tidy and neat build. So then this is when the robot was installed there. Again, a very, very simple installation. You'll see the amount of bar work that's actually around the robot. It's very, very minimal. So, you know, it makes the installation very quick. If you look at a job like that at Grazeway and a single robot, our team would have that fitted probably in 3 days. So, you know, it's just everything is done right along. And I suppose a lot of that is down to having good drawings developed by the project coordination team, detailed builder spec drawings that we know can be followed easily and that everything will be done right. And then it's the project coordinators having follow-up visits with the likes of the builders, meeting the plumbers, the electricians, just to make sure everything is right so that when we do come to fit a robot, we can drop it in and set it up. So here we have another farmer who decided to develop his existing parlour take out the existing parlour and turn it into a robotic milking system. So he took out the parlour and covered that over with a flow channel, a slatted flow channel. Again, the decision was made in late November to go robotic milking. So he had to move quick, I suppose. So we developed detailed plans with the aim of installing the robot in the last week of January. Again, we had to look at where there was going to be potential for expansion with the second robot down the line. And the total cost of the building work for this farmer came to approximately 12,000, and the slats alone cost about 2,500, and then there was about 5,000 of that spent on concrete work as well around to bring up the levels. So if we look, this is the plan. So marked in green is where the first robot was installed, sitting just off that slatted tank. Again, it was looking at trying to do a quick and efficient build that we could turn around in, 2 months, 6 weeks. But we also looked at how you could leave expansion down the line and where the potential for that would be. So the potential expansion was down at the end of that where the existing parlour was, with the second robot in perpendicular to the first, kind of they'd be in an L shape. And this also gives you the options when you do go to that second robot that you can separate this area as well. So again, just a simple install. Now, while we've had a good share of retrofits and converting existing sheds, there's also a certain amount of new builds, and I suppose we've had a lot of them over the last couple of years with the amount of farmers that have swapped over to robotic milking. So we see here, this is a design, that we'd have drawn up ourselves, present to farmers working with what they want. So we have our 2 robots, again, sitting off a slatted tank, and the green area then is cubicles running away from the robots. This shed, you'd be feeding on either side of the shed. So again, this is one robot installed, probably the room built for a second robot, so that it could be installed down the line, maybe at that second stage of expansion. Then to one side of the robot room, we have our cubicle separation area. To the other, we have our straw separation area. To the back, we have our dairy, our compressor, our office, and everything that's needed in that area. What this farmer also put in was a small area where he could maybe hold 5 or 6 calves, because I suppose this shed is on a Greenfield site, away from other sheds. So we needed somewhere that we could hold calves for maybe a day and then bring a group of 4 or 5 over to the existing sheds at the one time. So every build, I suppose, is different, and it's dictated by the needs of the farmer and what you're trying to achieve. He also went with a small treatment pit at the back of that straw separation area. Again, as I mentioned earlier, the big advantage of having such a large straw separation areas, you can sit your robot, a potential third robot down the line, can go into this area, I suppose, with a minimal build and not having to spend too much taking out walls or concrete or anything like that. So it's a good big open area that allows for that potential third robot down the line. Again, we ran our one tank running across in front of the robots and underneath the Grazeway. So, a lot cheaper than turn around and having to put in 2 or 3 different bits of tanks to facilitate the development. And the shed leaves itself open that it can be developed on further down the way, another 70 cubicles put on, and maybe a tank run across there if you do need additional slurry storage for pushing to that 130, 140 cows. But it's a very, I suppose, good layout that is working well on a good lot of farms. And now I suppose the costs of going down, the new build route on a greenfield site, you're looking at a cost anywhere from 1,500 to 2,000 a cow of an investment on the building side of things to get the slurry storage and the cubicle numbers and everything in place. So this is one example that went in last year. Again, this farmer was going for an indoor system, so probably looking for that bit of extra comfort. He installed the first robot, again, left space that he could install the second robot down the line if he desired. It went with something a little different here where the office is up above the robot room. So you're looking down out on the cubicles when you're in the office like so. Again, we put a lot of focus on these type of sheds, on area to move around through the shed, no dead ends, good loafing space for the cows, so that, because you're relying on your cow to get up, walk to your robot, eat and lie down again. So, you have to do everything you can from the design side of things to make that as easy as possible. But I suppose a lot of that is done at the planning stage. So we put an awful lot of effort into getting the right plan for the farmer. So, looking at what the existing facilities are in the farm, looking at where he can calf cows, because look, one of the big jobs in any farm is calving cows in the spring, getting them into the robot, getting them milked and letting them out to grass. So, you're looking to see how all these interact with each other and where your calving facilities are in relation to where your robots, and whether you need to incorporate a big calving area or a smaller calving area. So this is another similar, I suppose, greenfield site. Again, this is a slightly wider shed. It's 3 rows of head-to-head cubicles, whereas the last one only had a double row head-to-head cubicles. So this is it then looking at from the outside. Again, a tank running across in front of your robot and a room built to hold the second robot down the line if possible. This shed went with about 100 cubicles or 104 cubicles. So it gives, it's kind of halfway between that first robot and second robot. So it means that if the farmer is to expand the first year, he probably wouldn't need to spend anything on more cubicles. Again, we're looking at the back of the robot rooms here, and we have a cubicle separation area. This farmer has about 12 to 14 cubicles in this area. So these cows can cycle around the robot and they'll get back out to this area. Then if we move back further again, back behind that cubicle area, we're coming to a large straw bedded area. So this was a round roof hay shed with a lean-to off it that we said we try and incorporate into as a calving area for the setup. So now when a cow is on the point of calving, she's moved from that cubicle separation area into the straw area. And then after she's calved, she's moved from the straw area back out to the cubicle area. So the fact that it's easy to move between the two areas means that you're not going to have cows on straw for longer than you need them to be, and hopefully, reduce the amount of straw that's needed. Also, one of the nice aspects of this is that when cows are feeding, they're out on a solid area. They're not feeding when they're on the straw. So again, just helps to keep things clean. So I suppose that's giving you a very brief rundown of the different systems that that we have installed, from your retrofit into an existing shed to the new greenfield site and everything in between. So I suppose just given the number of robots that have gone in, we've come across jobs of all shapes and sizes. One final thing to mention, I suppose, is that if you are thinking of going down the robotic milking route, there are TAMS grants available to do so. So I suppose one thing to be aware of is that this tranche closes on the 5th of June. So if you are thinking of doing something in the next 18 months, you would be looking at trying to get an application in before that date if possible. For a general applicant, you can get a grant of 32,000. For a young farmer, you can get 48,000. And then if you're in a partnership, 2 farmers together, you can get anywhere between 64 and 96,000, depending on what the applicants are. So I suppose one thing that maybe a lot of people don't know is that to apply for a grant on a robot system, unlike a slatted tank or a shed, you don't need planning permission. So you can put in the application without planning permission. If you want more information on the grants or anything like that side of it, we said we wouldn't go into it too much here. Please feel free to give any of us a call. But just be mindful that the deadline is the 5th of June. And in the last couple of tranches, we've seen, a high number of applicants. So it's worth getting in. So look, that kind of brings to an end my portion of the presentation. So if you have any questions, feel free to ask.
There should be a chat facility, folks, there on the bottom of your screen if you have any questions. But I see some of you have already worked that out. So the first question is from Jim, William, and Jim's question is, how far can milk tank be from the robots?
I suppose every job is different. We have tanks located, up on 100 meters away from the milk tanks, milk tanks located up to 100 meters away from the robot. So, it depending on the layout of your line, and if you can get a straight line over to the tank, it's very manageable.
Okay. A question from Paul: Why would you go for a checkout design rather than a head-to-head?
So I suppose we maybe said a bit on it there, but the likes of you're looking at that checkout system for the higher herd numbers. So if you have 200 cows all going into the robots from one side and coming back onto the same tank, you have a lot of cows moving in that one area. So it just helps to free up the area going into the robot, and maybe helps get that bit more of a better throughput through the robots on a larger herd. But for the the 2 robot farms, we wouldn't see it as being necessary, and we have a lot of head-to-head systems working very well.
Kieran is looking for any more detail on that retrofit single robot.
Retrofit single robot. So as in.
Do you have a video of that? Is there a video? Hold on 1 second. I think we have a video of that.
Yes.
Let's see if we can play it.
So this is a single robot that was installed along the side, or kind of along the side of an existing Parlor. So the Parlor was taken out probably the first week of December, and the decision made to go robotic milking. So you'll see here when a robot is being lifted in, it's very quick, a quick thing to do, as long as the robot room has been prepared beforehand. So we'll see here the robot just simply lifted in and set in place. Then after this, there's probably about a day and a half for the robot itself, to connect everything up and do all the little bit of bar work around the robot that's required. So again, this is before and this is after. So the Parlor, the pit was converted into a flow channel that went into an existing tank. And you're trying to keep a meter off that tank with your robot to comply with the grant as well. It's a requirement of it.
Okay. Have you ever got the plan wrong? Is a question from Jim.
You might get it wrong the first time, but you go through with the farm. You present the first option to the farmer, and you talk through it, and you see what could work. So, it's not a case of going out, visiting a farm once, developing a plan, and then that's it. You're going over and back a few times to get a plan that ticks all the boxes, I suppose, and achieves what you want to achieve.
I could probably add in, we're Lely Mullingar, we're at this 8 years, and we've over 300 robots that we've installed ourselves. So we've probably learned a lot in the last 8 years. So there is some projects that if we were to do them again, we might have given the farmer a few more options that might have allowed it work a little bit better, if we're honest. We didn't always strongly recommend automatic drafting systems. We didn't always strongly recommend the slatted tank in front of the robots, but experience taught us that if you can persuade the client to consider that, he'll be glad that they did.
I think there's a question there on do you have to have a tank running across in front of the robots? And I suppose the short answer is you can situate a robot anywhere on a farm and it'll milk cows, but it's everything around the robot that will dictate the success of the system and how well it works. So if you don't have a slatted tank in front of that robot, you're going to have a big area where you're going to have a lot of cows moving over. So it's going to be a very dirty area that's going to be very difficult to keep clean. So there'd be very, very few jobs that if any, that wouldn't be situated off a tank.
John Walsh is, can cows be accommodated in a shed not attached to a robot shed, i.e. where there is a few cattle sheds in yard but not beside each other?
So yeah, again, I suppose like we have farms that might have cows coming from 3 different sheds to the robot area. And what I would say is a lot is dictated by your calving pattern and the land type you have on. So, you know, if you're in good land where you can get cows out early and they can stay out, you might only need access for half your cows. You know, by the time the first half of your cows are calved, they're going out to grass. So you only need cubicles for those cows around the area. So you don't necessarily need cubicles for every cow around the shed. We also have other jobs, I suppose, where there's on a greenfield site where, say, the cubicles might be located one side of the road and the farmers turned around and built a little shed and the two robots on the other side of the road. But again, that's the system. They're in the part of the country that when cows go out to the robots, they don't generally come back in because the land is that dry. But you can have cows walking over and back. But I suppose you just need to be conscious of anywhere that cows are walking a lot is going to be a dirty area. So, you know, if you don't have a tank or anything running between 2 sheds and you want them to come over to your robot, you're just going to create a dirty area.
A question from Chris. In grazing season, what distance will cows walk to the robot from paddocks? Chris, and it goes on about travel and cows traveling. Chris, we're doing a webinar next Tuesday on grassland management and grazing management, and we're going to get into that in detail. We would have touched on it in last week's webinar, which is recorded. So the link is there. Anyone who's registered should get a link to last week. So there's a little bit on it then, and there's a lot more detail on it next week. So if you, we're not just going to get into that now. David has asked, what size area in terms of length would you need for a house system? Or what size area in front of cubicles would you need for a house system, including auto foot bathing, etc.?
Well, again, you're looking to have that 5 meters plus in front of your robot, where possible. Like, I suppose when you're working with existing sheds, you know, you could be down near a 4, but ideally, even for a house system, you're looking at giving them plenty of lounging area. I suppose the one thing you don't want to, in a house system, I suppose it's somewhat different. Like cows can walk anywhere from between about 200 to 500 meters a day in a shed in a fully housed system. So you're trying to provide an environment that will allow a cow to walk from a cubicle to a robot and back. So, you know, looking for wide passageways that give, you know, cows can move by each other so that a shy heifer doesn't have to move through bully cows. So you're really just trying to, I suppose, provide more than one access route either to the feed face or to the robot. Because if you're looking at that type of system, you're trying to get cows milked 3 times a day. So, you know, there's that bit extra focus on comfort. And you probably saw that in some of the pictures of the sheds I showed there of the house system. It's just that bit higher of comfort and space in the shed.
Another question from Kieran is, what is the biggest grazing farm with robots? So the biggest grazing farm, Kieran, that we service, we're only talking about our own customers, the people we've experienced with. I have a client in Meath with 6 robots. They're milking, I think, 425 cows the last time I looked, and it's a spring calving grass-based system. And we have another few 6 robot projects on the go that show hopefully will be operational in the near future. And we've a huge number of 3 and 4 robot farms. So when things free up, if anyone wants to go and see them, that can be arranged. We can show people around those farms and see how it's working. There's a question here from Christine. What is the ideal number of cows to one robot? I might take that one as well, Christine. It depends on the type of cow you have. If you have a big, high-yielding Holstein cow and you want to milk her 3 times a day, say a cow doing 10, 12,000 litres, we'd be looking on a new A5 at about 60 cows. Whereas some of our clients, they don't want to milk their cows any more than twice, because the type of cow they have, there's no point in milking her anymore. They're spring calving grass-based systems. Majority of the diet is grazed grass, 5,000-6,000 litre type cows. So that type of cow, they're looking to have about 80 cows per robot with that type of cow. So the largest, we have one client who's got 90 cows on his robot, but that's not something I'd recommend. But if you are going to be pushing the boundaries, the whole yard plan and cow flow is even more critical. So we would spend a lot of time on that. And the 300, probably near 350 robots we've installed, we've learned a huge amount from our customers as well, what works and what doesn't work. Something here from Eamon suggests mentioning planning permission on retrofit not required.
So yeah, if you're converting the existing shed and you're not altering the outside or the appearance of the shed, then you don't need planning permission. So if you're like one of them jobs there where there's a robot being fitted into a shed, you don't need planning permission for that. So yeah, it's just something to note.
On a 100-acre greenfield site, this is from James. On a 100-acre greenfield site, is preferred yard location in Centre Point? I think Sean might have hit on that, James, last week. If you look at the webinar on the grazing layout, he goes into that in a bit of detail. So we wouldn't be advocating putting in the Centre Point. And if you look at that, Sean will go into that in a bit more detail. And we'll probably refer back to that next week's one as well.
I suppose you're looking at it as well how everything else is going to work. You know, the access for yourself to that yard. And if you're breaking up your grazing platform into A, B, and C, you might be breaking that up to 40%, 40%, and 20%. So it doesn't necessarily need to be in the middle of the yard or the middle of the farm. And you're looking at how you get access, you know, access for your milk lorry and for machinery and everything into that as well.
Sean wants to know, is the grant scheme ending on June the 5th? It's not ending on June the 5th, Sean. But if you apply by June the 5th, it'll probably be August, September before you have approval. And then you've 12 months from then to do something. So if you're looking at, I think what William was kind of alluding to is if you're looking at doing something in the next 12, 18 months, it will be worthwhile to have your grant application in and know where you'd stand. And I don't believe there's been any announcement of what's happening next year. So the current scheme actually ends at the end of this year. It's a bit unknown, is there anything they're going to follow for 2021? So a lot smarter people than us are suggesting get your application in if you feel you're going to be investing in any milking system. The TAMS grant is a fantastic scheme. So even if you're looking at a Parlor system, we'd be suggesting get your grant application in. It's a simple enough online application. If you're struggling to get someone to do it, give us a call. There's plenty of good people out there in Teagasc and elsewhere, private advisors who will look after you in that regard.
I suppose if you want, if anyone wants to get their farmyard walked or just to see, you know, if the sheds they have could be converted over, then both myself and Niall's email address and numbers there. Feel free to get in contact with either of us, and we'll try and get out in the near future.
Okay, I think with that, folks, we'll wrap it up. I appreciate everyone's attention. Appreciate all the great questions. If you want to watch this webinar again or any of the webinars that are part of this series, you should get an email with a link that allows you to look at the recording in your own time. And feel free to contact any of the Lely team here in Mullingar, Lely Center Mullingar, if you have any further questions. So thank you very much.